What if everything you thought you knew about the universe was wrong? Imagine a cosmos with no dark matter, no invisible glue holding galaxies together, no cosmic scaffolding shaping the universe. Would stars still shine? Would galaxies even exist? Or would the entire universe unravel before our eyes? Let's find out what the universe would look like without dark matter. Galaxies wouldn't exist as we know them. In the early universe, shortly after the Big Bang, tiny fluctuations in density, areas that were just slightly denser than others, began to attract matter through gravity. But normal, or baryonic matter alone wasn't enough to amplify these fluctuations quickly or strongly. That's where dark matter played a pivotal role. Dark matter, unaffected by radiation, clumped together early, creating gravitational wells that pulled in gas and dust. These wells acted like invisible hands shaping the first galaxies. Without dark matter, those small fluctuations would have remained weak and scattered. Gravity from visible matter would have struggled to pull material together in time to form galaxies. As a result, galaxies, especially structured spirals like our Milky Way, might never have formed at all, or would have appeared far later and in much smaller forms. The universe would look empty and chaotic, with stars scattered randomly across vast distances instead of being organized into majestic galactic forms. The universe would expand too quickly. Dark matter not only helps form galaxies, but it also counteracts the rapid expansion of space. After the Big Bang, the universe began expanding, and it still is. But the gravitational pull from dark matter helps slow this expansion in the early stages, allowing matter to clump and form structures. Without that invisible mass exerting gravitational influence, the expansion would have been faster, more aggressive. This would stretch matter apart before it had the chance to form stars or galaxies. Picture a balloon inflating so rapidly that any confetti inside gets flung to the edges before it has time to stick together. That's what our universe might have resembled. An overexpanded void with minimal structure, where matter is too thinly spread to form anything significant. This fast expansion would also mean fewer interactions between particles, gases, and matter in general, slowing down or halting the chain of events needed to form planets, stars, or life. Gravitational lensing would be weaker. One of the most fascinating proofs of dark matter is a phenomenon called gravitational lensing. According to Einstein's theory of general relativity, massive objects like galaxies bend space-time, and this warping causes light to follow curved paths. When we look at distant galaxies, we sometimes see distorted, stretched, or duplicated images. A result of light being bent around massive clumps of dark matter. If dark matter didn't exist, this bending would be significantly reduced because there would be less mass to curve space. The elegant arcs, rings, and stretched galaxies we see through telescopes wouldn't appear. More importantly, gravitational lensing gives us a way to map dark matter, to see the invisible. Without it, not only would our view of the universe look plainer, but one of our best tools for understanding cosmic mass distribution would disappear. Our knowledge of the universe's structure would be severely limited without the gravitational fingerprints of dark matter. Cosmic microwave background would look different. The CMB is often described as the baby picture of the universe, a snapshot of the cosmos about 380,000 years after the Big Bang. It's essentially a background glow of radiation that shows slight variations in temperature, which reveal how matter was distributed in the early universe. These temperature differences, or anisotropies, are influenced by dark matter. Dark matter helps shape the peaks and troughs in the CMB's energy spectrum by adding gravitational influence without interacting with light. patterns in the CMB would be altered. The acoustic peaks, which show how sound waves move through the early plasma, would look different, and the temperature fluctuations would be smaller and smoother. This would suggest a universe where matter didn't clump well, echoing the same story of weak structure formation. In fact, if scientists had first observed the CMB in such a universe, they might never have theorized galaxies could exist at all. The early clues would point to a calm, uneventful cosmic future. Stars might be fewer and farther between. Stars form in clouds of gas that collapse under their own gravity. But in the early universe, before the first stars existed, it was dark, cold, and filled with neutral gas. Dark matter helped by creating gravitational wells that pulled this gas inward, kickstarting the process of star formation. These dark matter halos were the seeds from which galaxies and stars could grow. Without these invisible cradles, gas would still collapse eventually, but much more slowly and less efficiently. The universe might have gone hundreds of millions of years longer without forming its first stars. And when stars did finally appear, they might be scattered across space, not bound into galaxies. This would dramatically reduce the chances of planetary systems, habitable zones, and the complex chemistry needed for life. In short, a universe without dark matter could be nearly starless, vast, cold, and bleak, with tiny flickers of light separated by immense cosmic voids. Life, including humans, might never exist. Perhaps the most sobering consequence of a dark, matterless universe is that life, including us, might never have emerged. Life requires stars. They provide the heat, light, and elements like carbon, oxygen, and nitrogen, all forged in their nuclear furnaces. Those stars need galaxies to form, and galaxies need dark matter to pull the necessary ingredients together. Without this invisible force working behind the scenes, there would be fewer stars, fewer planets, and perhaps no stable environments for life to evolve. Even if a few stars and planets did form, they might be too isolated, making the chances for complex life vanishingly small. Evolution is a long, delicate process, and it relies on a stable environment. A universe without dark matter might be too chaotic or too empty for this to happen. In that sense, we owe our very existence to something we can't see or touch. Dark matter may be invisible, but its influence is written into every atom of our being. The universe without dark matter wouldn't just be different, it would be almost unrecognizable. It's the silent force that sculpts galaxies, moderates cosmic expansion, and lays the groundwork for everything from stars to humans. And yet, we still don't know exactly what dark matter is. We only know it's absolutely essential. So, the next time you look at the stars, remember, their very existence depends on something we cannot see but know must be there. The mysterious architect of the cosmos.